Hello everyone and welcome to this tutorial. From previous tutorial we have started to build the actual project. First we have started with data pre-processing. Here first we have imported the libraries and dataset. After that we have done data exploration. Here we have seen statistical summary and the information about the dataset. After that we have seen categorical and numerical columns. And then we have dealt with null values. Now add a subsection, dist plot, add few cells. Here we will draw dist plot of the target variable. Type plt dot figure, specify the fig size 16,9. Now define a variable bar, use Seaborn library sns dot dist plot, and in parentheses specify the target variable sale price. After that bar dot legend here we will add skewness as well. Point to f, that means we are taking only two values after the decimal point. Then use the dot format method. Specify the target variable sale price dot, use the method skew, and at the end plt dot show and execute. Great. Let us understand this. So here we have plotted sales price versus density. So most of the sales price is concentrated around the 2 lakhs. You can see here. And this is the skewness. This one, this line. So this is the skewness as you can see, and here we can get the probability distribution. Add a subsection. Correlation matrix. Define a variable dataset underscore 2, drop the target variable dataset dot drop, specify the column sale price, execute. Check the shape 1460, 76. These are the number of observations 1460 and these are the number of columns, total 76 columns. Type this new variable dataset underscore 2 dot correlated with, in parentheses specify the target variable sale price dot plot dot bar. Here also specify the figure size 16,9. Then specify the title correlated with sale price, add the grid lines, grid is equal to true. That's it. Now execute. Great. Let us understand this. This is the title correlated with sale price. So these are the all independent variables. and we plotted the correlation of all these independent variables with the target variable, sale price. So you can see these three variables are mostly correlated, that is positively correlated. Then these four are also positively correlated. These three are the little bit negatively correlated. Then these four variables are positively correlated. So most of the variables are positively correlated up to this one. And these seven variables are not that much correlated. So here we are getting more information about the dataset. Let us move forward. Let us draw the heat map. PLT dot figure. Specify the fig size as we do always. Here I will specify 25, 25. Then define one more variable AX is equal to SNS dot heat map. First we have to specify the data. Data is equal to dataset dot correlation. Here we have to specify more arguments as well. CMap is equal to cool warm. After that specify annotation is equal to true, and at the end specify line width 2. That's it. Now execute. It will take a little bit time because we have a lot of columns. So this is our heat map, and here we have a lot of columns. That's why we are getting this type of heat map. Let us try to understand. Here you can see 0.83, 0.63, 0.52. Darker the color of a cell, that means these two variables are more positively correlated. Now add few cells. Let us try to simplify this. Define a variable high underscore CORR is equal to dataset dot this method for the correlation and execute. Great. Then define one more variable highly correlated features. High underscore CORR dot index. Then in square brackets we will use ABS. Use again this variable highly correlated. Select the target variable sale price, and this must be greater than 0.5 and execute. Copy this variable, check this one. Great. Let us understand this. So here we have defined a variable high underscore CORR, and this is the normal correlation, and here we are selecting only those features which are the highly correlated features. And to do that we are using this method dot index and ABS method. And here we have specified correlation with the sale price more than 50%, and these are the highly correlated features. Let us check the length as well. So there are total 11 highly correlated features. Now again draw the heat map. Copy this code. Paste. Here we have to change few things. Data is equal to dataset. In square brackets, here we have to specify this variable highly correlated features. And that's it. We don't have to change anything and execute. Great. So this is the heat map. I'll just change fig size 16, 9 and execute again. Great. So this is the heat map of highly correlated features. Here you can see This one 0.79, these two variables are more highly correlated. Then 0.71, 0.83, these two variables are also highly correlated. Then 0.82, 0.82, 0.83, 0.88, 0.71, 0.79 and all. So this is how we can simplify the heat map. Let us move forward. Now we have to deal with the categorical features. Add a subsection dealing with the categorical values. Check the shape of dataset. 1460 observations and total 77 columns. Now scroll up. In data exploration, scroll down. Copy this line, categorical columns, and paste here. Check the length as well. So there are total 39 categorical columns in this dataset, and we have to encode all these columns. Let us do it. Type pd dot get underscore dummies, and in parentheses we have to specify the dataset. Data is equal to dataset. Add one more argument. Drop first is equal to true, and redefine the dataset. So here we are specifying all the dataset as data. So this method get underscore dummies will encode all the categorical columns, as well as we are dropping the first column to avoid the dummy variable trap. Now execute. Check the shape of dataset. Dataset dot shape 238 columns. Previously it was 77 columns. Now check the categorical columns again. So there are no categorical columns because we have encoded all the categorical columns. Check the length of categorical columns. 0. That means we have successfully encoded all the categorical columns. So this is all about the dealing with categorical values. Now we have to split the dataset into train and test set. Splitting the dataset. First we have to specify x and y, that is independent variables and target variable. Independent variables, or we can say that matrix of features. X is equal to dataset dot, we have to drop only one column, sell price, and execute. So here we have successfully defined the matrix of features. Now define the target variable, or we can say that dependent variable. Y is equal to dataset. Here we have to select only single variable, sell price. That's it, and execute. Now after defining matrix of features and dependent variable, we have to split the dataset. And to do that, we have to import a class from sklearn dot model selection, then import train underscore test underscore split. Execute. So here we are importing this class train underscore test underscore split from the sklearn dot model selection. sklearn is the library and model selection is the module. Let us split the dataset. Xtrain x test y train y test is equal to, use this class train test split, and in parentheses specify x and y. After that specify the test size 0.2. So here we are specifying test size is equal to 20% and training size is equal to 80%. Add one more argument, random state is equal to 0, and execute. So there is a typing mistake, x train, then we have to specify comma, execute again. Great. So we have successfully splitted our data set into training and test set. Let us check the shape. X train dot shape, then y train dot shape, then x test dot shape, and y test dot shape. Great. So there are total 1168 observations in the training set and 292 observations in the test set. Let us understand this again. To split the dataset, first we have specified x and y, that is independent variables and target variable. After that we have imported this class from this library sklearn.modelSelection, and we have splitted the dataset 20% in the test set and 80% in the training set. So this is all about the splitting dataset. Now we have to do one more step in data pre-processing. Feature scaling. To do feature scaling, we will refer sklearn documentation. Open sklearn documentation. Then go to API. Now scroll down. Here we have to look for pre-processing. All this in alphabetical order. Pre-processing and normalization. And we have to use this class standard scalar. So open this one. Here you can see the description. Standardize features by removing the mean and scaling to unit variance. For the feature scaling, we will use this class standard scalar, and we have to import this class from sklearn.preprocessing. From sklearn.preprocessing, import standard scalar. Scroll down. So it standardizes the features by removing the mean and scaling to unit variance. And this is the formula. Z is equal to x minus mu, and this is divided by s. So mu is the mean of training samples and s is the standard deviation. Scroll down. So here we have to define an instance of this class like this. We will call this instance as SC, and this is the instance of standard scalar. I'll just copy this class, paste, that's it. And after that we have to use these methods, fit transform and transform method. Xtrain is equal to sc dot fit transform, and in parentheses xtrain. Copy this line, paste, xtest is equal to sc dot transform, and in parentheses xtest. That's it. Let us understand this again. First we have imported this class standard scalar, and we have imported this class from sklearn.preprocessing. After that we have defined an instance of this class, and then we have used fit underscore transform method for the training set and transform method for the test set. Execute. Great. Now check X train and X test. Here you can see the range from -3 to +3. That means we have successfully applied feature scaling. So this is all about the data pre-processing. Let us revise what are the steps that we have performed in data pre-processing. First, we have imported the libraries and dataset. Then we have done data exploration. After that, we have dealt with null values. Then we have drawn this plot. After that, we have drawn correlation matrix. These are the correlation and this is the heat map. We have simplified the heat map as well. After that, we have encoded the categorical values. Then we have splitted the dataset into training and test set. And at the end, we have applied feature scaling. So this is all about the data pre-processing. From next tutorial, we will start the model building process. Till then, happy learning.